instructions?
I have no back pointer.
Okay.
That's what you're missing. There's no back pointer. We debated putting the back pointers in, and the problem is it just adds more memory, and we're trying to become a little bit smaller.
Right. Well, just now you just said that there was no policy for maintaining coherency across different machines, but for file systems, network file systems, effectively, is it true then that if you have a user mapping a file in on one client and some other user, for example, to a database, wants to read-write same file on some other client, you have forced every single user on the first machine to get stale data?
That's right, and it's the database's problem for letting that file be opened, right, because it didn't do an exclusive open when it first opened it, and the database is not managing its data properly. We provide all the mechanisms for the databases to prevent this from happening. It's up to the application to make sure it implements its calls properly so it doesn't get burned by this.
Right. Well, we have a file system that's distributed in nature, and we do all the coherency management ourselves. The problem is that NT has now effectively precluded a distributed shared memory implementation to exist with NT machines in that environment. Is that true?
The current way it's designed, it doesn't provide the notification you need to do that. That's correct.
Okay. And finally, in a network environment, you've got a server, an administrator wishes to upgrade an executable. You kept talking about Excel. And there is some user who's got Excel running on his machine. Let's say there are 50,000 nodes out there and 4 of them have got Excel running on their machines. And now I, as an administrator, cannot upgrade the executable on my server because some user refused to shut his machine down in the night, and he's got this file mapped in. Is that also true?
That's a deficiency in our file systems, right? That's the way we've implemented our file systems. Your file systems could do, there's rename differently, right? You could actually lose the name and still have the file on the disk. So that file handle's still open and the pages are happening in and out. Our file systems decided they didn't want to go through that trouble to make that work. Okay, there's file systems out there that support this today.
Right. Well, okay, one final thing, hopefully, that I can do is if no user is running this executable or executing this file, and you have a reference to it, you've kept those pages in, and then I decide to upgrade or change the executable on the server, I can call force section closed, and since you know that nobody's got the file mapped in, only you have a reference to it, you will allow those pages to be released. Is that correct?
Correct, but the call to MM flush image section will get rid of those pages.
Okay.
You don't have to call force section closed. As soon as you call flush image sections, you'll get true will be returned and all those pages will be released. And back to the previous comment, the reason that the file systems don't do this is FAT, which is the first file system we did, doesn't allow this on DOS. So for consistency's sake, they implemented everything with using a similar DOS model so people wouldn't go between file systems and say, holy cow, I can do that here and I can't do it over here. And we get all sorts of calls to the support people wondering why sometimes it worked and sometimes it didn't work.
One final thing, if I may, if I have a page, if a page fault occurs because there is an executable, if there's a file executing, can I block while satisfying that page fault read for a memory mapped file as opposed to a paging file?
Yes, you can always block because you might have to because of resources or whatever. So anytime somebody's doing a read from a mapped file, you can always block.
Okay, thank you.
Always block on a read.
By definition. I'll let that go. Thank you.
Okay. Do you make a distinction between the way you handle a page out to a paging file versus a page out to a memory mapped file to flash out dirty data, dirty pages from a memory to
No, they're both done identically. The only distinction we made is which thread we do it from, because we know when we're going to the paging file that you'll follow rule number 6.
Okay.
The one that says you won't block. Whereas for memory map files, we know that you might have to block. There might be something that you're waiting to complete. You might have some other purge in progress. There's something you're waiting for.
So it's okay to block on that path on the page out to a memory map file.
If you have to block, you can block. If you can design your file system such that it doesn't block, you shouldn't block. Now, one of the things that I mentioned is there's a couple of times when the memory manager acquires the file, the high up resource, and David Goebel will talk about that. We acquire that resource in two cases. Number one, the modified page writer acquires it before doing a paging, an out page. Before we do a page write, we'll go get that resource for the page and IO resource, it's called. We'll go get that shared. And the other case is when we're calling map view a file, we'll go get the resource as well. And this solves deadlocks in the case of the write, where we try to do a write and you have a purge or something like that going on, and of course they're never going to complete because they're going to block on each other. The other case of the map file is, imagine the cache manager trying to map the file at the same time a user's trying to map the file, and the cache manager has a resource. The user doesn't have the resource, but the user got snuck in that one window, and now he's waiting to get the resource to check on the file size. Okay, because we have to, if he says about 10 megabytes, we have to make sure it's a 10 megabyte file, which requires us getting a resource when we call the file system. So we deadlock there. So we solved that by, in these two cases, getting a file system resource. And David Goebel will talk more about the rules in great detail about how that all works.
Also, can I tell whether, on a read, can I tell whether I'm being called following a page fault or just being called by the cache manager?
Yeah, you can't tell on a read who's calling you. The same goes on, you can't really tell on a write who's calling you either.
All right. Thank you.
Yeah.
The culture book says that at least the first implementation of NT uses 3-6-page models, even on disk and also. And I've heard that another thing is we have predefined page tables as far as we see that's increasing their memory cost added disadvantage. Is this a forced operating system?
The comment was in the PowerPC, the comment is in the custard book, it refers to NT having a 386 page table page implementation, and we even implement that on MIPS, on Alpha, and now we're doing the PowerPC port, and it's costing us a little bit of extra memory. And the comment is that portable, and the answer is absolutely yes. We had the PowerPC port running. In fact, IBM had the PowerPC port running in quicker than any port we've done so far. So it's.
But you have to change both types of page tables.
We have to maintain both types of page tables. It turns out it's trivial. I mean, all the code is common code, so all they have to do is write the backend code that maintains the processor unique model of the paging. All the common code is maintained by the memory manager.
True that an NT process on PowerPC's got a 3-6 page tables around just to feed the PowerPC.
That's true. On PowerPC, we have all the 386 processes. Now, the interesting thing about this, it means that anybody who understands the memory manager can walk up to a PowerPC and debug a file system. Guess what? Because the cache manager layout and the memory manager layout are identical. So you don't have to be concerned that it's a MIPS, a PowerPC, an Alpha, or x86. That whole structure is identical. And if it weren't for this, we wouldn't have people being able to debug the file systems and get these ports done as quick as we can. And the PowerPC port isn't released yet, but IBM's been demonstrating NT running on the PowerPC now for over 9 months. And the main problem that if you want to really talk about why it's not released, is we have to do the testing, and the new chips are coming out right now. It's getting those new chips, getting machines and getting the testing done that's slowing us up. And there's some improvements we're making while we're doing the PowerPC stuff, because we're always trying to make things better. So.
All right, let's take a very quick break, maybe 10 minutes. And